So we're watching that story, and we've been talking about it earlier on. Other types of scary experiences on planes. Well, turbulence, that's nature, isn't it? But it's getting worse, apparently, and we can put that down to climate change, according to Dr. Paul Williams. He's from the University of Reading. And Dr. Williams, hello and good morning to you.
Good morning, Sean.
It always scares me anyway when this turbulence happens. Well, depending on the severity of it, it can be a pretty unnerving experience for a passenger, and of course can be lethal as well. You believe that we're going to get more turbulence when we're flying in the future?
Yeah, that's right. You're not at all unusual in being fearful of turbulence. Apparently it affects about 20% of people, so about 1 person in 5. But if you look at the statistics, it is very rare. We think there's about 1 serious injury or fatality for every 1 million flights. So the chances of it being you are really very small. But yes, as you say, we think it's getting stronger as the climate changes.
What's happening when the plane encounters turbulence?
Yeah. Well, if you imagine the atmosphere as being made up of layers, sort of stacked on top of each other, and all those different layers are moving at different speeds, moving horizontally. So there's a kind of a friction as they rub up against each other. It's what atmospheric scientists will call a wind shear. And if those wind shears get too strong, then the atmosphere breaks down into turbulence and you get these fluctuations, basically forces pushing up and down on the wings of the plane, and that's what you experience as a bumpy flight. It's the plane moving up and down, and sometimes those vertical motions can exceed 1 G. In other words, they're stronger than gravity, so you can be moving down faster than gravity can pin you down, and that's why people can sometimes, in strong turbulence, lift up out of their seats if they're not buckled in.
Yeah, how do the planes cope with that?
Planes cope fine with it. They're built to technical specifications that exceed just about any turbulence encounter that has ever been experienced. I'm aware of a small number, something like 1 or 2 planes that have suffered damage in very strong turbulence. There's a classic example that people talk of when an engine did break off mid-flight in very strong turbulence, flying over the Rockies in the US, but this almost never happens, and that's really very rare.
I'm sorry you told me about that one, because I've always when I've experienced turbulence, I've always had it in my head that it doesn't cause problems for planes. But anyway, it's very rare, you say. It's predictable then, in if you're a pilot, it's predictable, is it, when they're going to encounter turbulence, or is it often unpredictable?
We've got methods for predicting it. I mean, the particularly hazardous kind of turbulence, because there are different kinds. I mean, if you fly through a cloud, that's always turbulent because of the upward motions within the convection within the cloud. But the hazardous kind is called clear air turbulence, and that's really above the clouds when the plane is at its cruising altitude above the weather systems, and it's called clear air turbulence precisely because it's invisible. There's nothing on board the plane that can see it. The radar, the electronics, it's invisible to the pilot's eye. So this is the dangerous kind because typically the passengers could be moving around within the plane, seatbelt sign switched off, and it just literally comes out of the blue. That's the dangerous kind.
That's a scary one. Well, they can all be scary, but that's that's the one you're not expecting.
That's the one that causes injuries. But there's a simple thing you can do to almost reduce your probability of being injured to zero, as close as you can get it, and that is simply to just remain seatbelted, even when you're not legally obliged to be seatbelted. If you just keep that seatbelt fastened, you're virtually guaranteed not to be injured.
We've been talking about car seatbelts earlier, so we're repeating a few subjects here today. This is now seatbelts on planes. Keep them. They usually say keep them loosely fastened, don't they, for your safety? Yeah. You don't want to be uncomfortable. You want to have a bit of slack, but you certainly want to make sure that if the plane starts plummeting down faster than 1 G, then you want the seatbelt to be taking you down with the plane rather than lifting up inside the cabin. And that's the commonest cause of injuries is people lift up and break a bone when they collide with the airframe. Yeah. We're talking to Dr. Paul Williams from the University of Reading. We can experience more turbulence in the future. Will experience. You think we will experience more turbulence, getting stronger. more possibility of encountering it, you're saying, and worse levels.
Yes, well, there's two things. It's getting more frequent and it's getting stronger. And that's because those wind shear events, which are very common within the jet stream. Jet stream is a mixed blessing for planes because they'll try and get into it on an eastbound flight, for example, across the Atlantic, because they get a big boost to their ground speed. The jet stream can blow at speeds of up to 200 miles an hour or over 200 miles an hour on a good day. So planes will try and get into it on an eastbound flight. But there is a lot of turbulence in there. And we think that we have evidence now that because the jet stream is changing, as the climate changes, that we'll probably see possibly a doubling of the amount of airspace containing significant turbulence by around the middle of this century, but also an increase in the average strength of that clear air turbulence by between 10 and 40%. So it's the two things, really. There's an increase in the strength and also an increase in the amount of airspace simply just containing significant turbulence.
So, for instance, people coming from New York or Boston or America generally to Ireland, the plane would try and get into the jet stream there, would it?
It does, yes, that's right. And conversely, on the westbound route back over to North America,
the other way around,
trying to avoid the jet stream because it slows down. So there's interesting things. It's not just the turbulence that's changing, but the journey times, in fact, as well, because the jet stream at those flight levels is speeding up. So the eastbound crossing back over to Ireland from North America is going to get faster as the climate continues to change, and those westbound flights are going to get slowed down just because they're being buffeted and battling against those strong headwinds from the strengthened jet stream that's coming because of climate change.
So let's get this right. When we're flying to America, it'll get tougher to fly there, and it'll take longer. Yeah. And coming back, we'll be flying, but it might be very bumpy.
Absolutely right. We do think that we have good, we understand now why the jet stream is changing. It's all because of those carbon dioxide emissions. And we do think that we'll see more record eastbound transatlantic crossings. The current record is 5 hours and 16 minutes for a flight from New York to London. That's the non-Concorde record, I should say. But I do think that we'll see more flights in that category in the coming decades as the jet stream speeds up and eastbound flights surf on the jet stream, really, and get that boost in speed.
And how fast is this happening?
I've been looking at computer simulations, and what we've done is we've doubled the amount of carbon dioxide in the atmosphere in the computer model. So the question is, when will the amount of CO2 in the real atmosphere double? And that, of course, that depends on our future emissions. If we cut those emissions radically, then it will be towards the end of this century, perhaps, before we double. Whereas if we don't cut the emissions very hard, then it could happen sooner. It's all really, middle of this century, coming decades, that sort of timescale.
So is it possible to know, you say the pilot won't know where this turbulence is because they're up so high and there's no way of knowing, but is it wrong to ask then, or is it a silly question to ask, where is the most dangerous place to fly, or which area is going to be the most dangerous place to fly in? You mentioned the jet streams, obviously, to encounter this turbulence that's going to get so bad.
Yeah, it would be in the jet stream. That's the fastest, really, those really fast winds, a couple of 100 miles an hour. That makes the atmosphere unstable and it just breaks down into turbulence. The atmosphere just can't withstand the stresses and strains from those wind shears in the jet stream on a strong jet stream day. We do have ways of making forecasts of the clear air turbulence, I should say. We can take computer models and try to estimate where and when it will be turbulent, and we do that so pilots have access at the start of each flight to a map of where we expect the turbulence to be, and they will use that information to route the flight. But the forecasts are not perfect, and we need to do some more research, really, and improve the skill of those forecasts.
When you experience some of the turbulence, you wonder why there aren't more accidents. You said the planes are very strong and all of that, but the type of turbulence you're talking about, I mean, how strong would they need to be? I mean, they're getting bigger as well, some of these big double-decker planes and that. Yeah.
Well, the bigger the plane, the better, actually. Right. It's most of the injuries and certainly the fatalities, we think there are about 40 fatalities a year in the USA. They are small planes, private planes, maybe with just the pilot on board or just a small number of people on board. The big planes, the 747s, because they have the inertia and all of that mass, all of that weight, they can withstand more turbulence without really feeling it. So the smaller the plane, the stronger the turbulence.
So the bigger the plane, the better.
Yeah, exactly.
Okay, well, fascinating stuff. And Dr. Paul Williams from the University of Reading, thanks for joining us.
Great to talk to you, Sean.
Thank you. It's just turned 10 to 12, and we'll be back after these.